The region bounded by the lines x equals -3, x equals 5, y equals 2, and y equals 4 is rotated around the x-axis. Find the surface area and volume of the resulting solid. Let's start by just sketching this real quick. So we've got our axes, and I'm going to be very careful here just so that we can get a good picture of what's happening here. So x equals -3. There's x equals -3 and 5. 1, 2, 3, 4, 5. Now those are vertical lines. I'm going to go ahead and do them in different colors just so that we're able to see that. So there's x equals -3, and there's x equals 5. Oh, that's nice and perfectly vertical. Okay, and then we have the lines y equals 2, so 1, 2, and y equals 4, 3, 4. So let's go ahead and draw those. And that's up at 4 and at 2, going, of course, in both directions. All right, so we're looking for the region bounded by these lines. And that region, of course, is going to be now this rectangle here. So I'm just gonna erase the things that are outside that rectangle, so that we can be very clear about what region we're looking at. Okay, so this is what we're looking at here. Okay, the region there in that rectangle. And we are rotating this around the x-axis here. And so we want to see what we're going to get. Now, to draw this, we're going to take this shape here. We're just going to copy it down below. So now you just draw the reflection across the line that you're rotating around. So 2, 3, 4. And I'll use the same pictures. So I've got, sorry, the same colors. So I've got those, and then these. Okay, so I've drawn my my copy down here, and then we need to connect. And an easy way to draw is to connect vertices with kind of a rotated line, a curved line, to show that it's rotating. So we've got that. Okay, so we've got that rotation there. And then that coming down here, kind of the same thing. Now I'm gonna try and draw this with some dotted lines to indicate what's kind of behind what we're looking at. So kind of like that. Okay. All right, so there's our shape, and we can kind of see that it kind of looks like a cylinder, except it's not the whole cylinder, right? It's only this portion from the rectangle. So there's kind of this hole in the middle. If we try and kind of visualize that hole, it's this, and that right there is a hole that kind of goes all the way down to the end, okay? So really all we're doing is, right, looking at this kind of, and I'm going to go ahead and color this in so we can kind of see that. So it's that, and that extends all the way down, and that creates our solid. All right, so we want the surface area and the volume of this solid. Let's start with the volume, because it's going to be a little bit easier. The volume, we can see that this shape is, we've got a large cylinder, but then we've just cut this cylinder out of the middle. So we're just going to subtract the volumes of the two cylinders. So the volume of the larger cylinder, well, the volume of the cylinder is pi r squared h. Okay, and so what we're going to do for the larger cylinder, we're going to have pi. The radius, if we look at that's kind of from the axis out to that far line, that's going to be 4. So pi times 4 squared, and then times the height. The height of this cylinder is that height right there, which is the distance between our x values, we can see here, which is from -3 to 5. That's a distance of 8. Okay. Now that's going to be the volume of the larger cylinder, but we're cutting this middle cylinder out of it. So we're going to have to subtract the volume of this inside cylinder. Well, that's again pi r squared h. Pi r for the smaller is just going to be from the axis out to that closest line. Okay, so that's going to be a distance of 2. So that radius is 2 squared times the height, which again is the distance between the x values here, which is 8. All right, well now we can simplify this. So this right here is 4 squared is 16 times 8, which is 128. So we have 128 pi minus, here's 4 times 8, which is 32 pi. And that's 96 pi. Okay, so the volume of our solid is 96 pi. Now let's talk about the surface area. And this one is a little bit harder, I think. So for the surface area, we just need to add on all the different shapes that we have, the different surfaces of this solid. So I'm going to start with actually what's colored in here, which is the yellow. Okay, if we were to look at this kind of from the side, if we were to look from the left side here, what we would see there is this circle inside a circle. Let's move that. Okay, so this is what we would see, and we're looking for the area, okay, of this stuff around. Okay, that's what that side right there is. Well, we can get the area of that by just taking the area of this larger circle and subtracting the area of the inside circle. So the area of a circle is pi r squared. So pi times the radius of the larger circle is 4. Again, that was from the center up to that far line was 4. So pi r squared minus pi times the smaller radius squared. So the smaller radius is that distance there, which was 2 squared. This is a larger circle minus smaller circle. That's going to give us that area of that circle. Okay. Now that's equal to 16 pi minus 4 pi, which is 12 pi. So that's the area of that top. Notice that that's actually the same as the area of the bottom, right? If I were to look at this bottom here, the bottom of that, or top, however you want to look at it, the other side of that of this shape is the exact same. So we actually have 2 of these. Okay, so I'm going to kind of put this together. I've got 2 of those 12 pi's. That's the top and the bottom. And actually, you know what I'm going to do? I'm going to color code this so we see all those different pieces. So we've got 2 times 12 pi. Okay, and then we've got the outer surface of this cylinder here. I'm going to go ahead and do that. Look at that as like a green. Okay, that's like if I look here along this. I'm seeing it as the front of this cylinder. Okay, what I'm drawing right now, and then that wraps around on the other side, right, and goes around. It wraps all the way around. Well, the volume of, the surface area of the outside of a cylinder is 2 pi RH. Okay, so I'm going to add on 2 pi times that the radius of that larger portion, that was 4. So 2 pi times 4 times the height of this cylinder. That's that distance between the x values again, which is 8. Okay. And then there's actually one more surface here that we need to add on, and that's the surface inside this hole. If we look inside that hole, we've got another cylinder in there, really, right? If I'm just going to draw it here in orange, so we're seeing it. Okay, there's this cylinder in there, and we need the surface area of that because that's like this inner surface of this shape. So that's another 2 pi RH. 2 pi, then the radius of that inner circle there is 2 times the height, which again, the height of that cylinder is 8. All right, so there's a lot of stuff going on here. Let's go ahead and simplify a little bit. 2 times 12 pi is 24 pi. Plus, here we've got 2 times 4 times 8, which is 64 pi. And then 2 times 2 times 8, which is 32. All right, so adding these all together, 24 plus 64 is 90. And then, sorry, it's not 90, that's 88. Plus 32 is 120. So we get 120 pi here.